Okay, so let's see how to do these questions. So let's do this question first. Number 2. Game plan is what? Isolate the radical, right? So here we have plus x, and now what do we have? 3 plus x is equal to 4 squared of x. Now here, if you're thinking, oh, I want to isolate the radical and divide 4 on both sides, you can. But it'll make your life, your life won't be too difficult if you just square both sides here. Because if you were to, let's say, you said, Mister, okay, I thought I had to do this. I had to do 3 plus x over 4 is equal to square root of x, because you said isolate the radical. And this is isolated compared to this. But the idea of isolating the radical is to get rid of the radical. And if I were to square this now, because if I were to get rid of this, I have to square it, this is a little annoying with the 4. You'll notice that you'll get the same thing, but it's not too bad, because this squared is just 16x, okay? And just so you can see, 4 squared of x squared is equal to 4 square root of x times 4 square root of x. 4 times 4 is 16. Square root of x times square root of x is x. Okay, so this is just equal to 16x. And notice we got rid of the radical. And here, there's going to be no more radical. So life is, it's okay. So here, if you FOIL this, you should get 9 plus 6x plus x squared. I'm not going to show you how to do this. You know how to do this. Solve it or figure this out by yourself. 3 plus x squared is equal to 3 plus x times 3 plus x, and you FOIL it. Okay? But once you FOIL it here and you have this, notice in this other video before, let me just take the paper real quick. Where was it? Okay. Here, you just want to put in standard form. So here, this is x squared plus 6x plus 9 is equal to 16x. Actually, let me find that paper. Where did I do with it? This one, no. This one, no. Where did I put that paper? I'm going crazy. Oh, here it is. Okay. When we did the other question before, remember, always put into standard form, right? So we have this and we put it into the standard form, and that's what you're going to do here. You just take this and put it into the standard form. And if you were to pause the video and say, hey, what's the next move? Remember, what was our move last time? It's to get 0 on one side, right? Why do we want to use 0? Why do we want 0 on one side? So we could eventually get something like this by using zero product property. Okay, so here this is minus 16x minus 16x, and now what do we have? We have x squared minus 10x plus 9 is equal to 0. And now here, what can we do? We could say x minus 9, x minus 1 equals 0. X minus 9 equals 0, x minus 1 equals 0, x is equal to 9, x is equal to 1. Okay? But you have to check. You have to check to see, maybe you get an extraneous solution. So the check is here. Let's do the check. Let's check one of them here and check the other one over here. Let's say x is equal to 9. Put this into the original equation, so 3 is equal to 4 times square root of 9 minus 9. So 3 is equal to 4 times 3 minus 9. So that implies that 3 is equal to 12 minus 9. 3 is equal to 3. This works. Okay? What about the other one? So x equals 9 works. What about x equals 1? 3 is equal to 4 times the square root of 1 minus 1. 3 is equal to 4, well, the square root of 1 is 1 minus 1. 3 is equal to 4 times 1 is 4. 4 minus 1 is 3. 3 equals 3. This one works. So x equals 9 and x equals 1 are the solutions for this. Did we get extraneous solutions? We checked them both, and they both worked. Let's look at the next one. Here we have this and notice that what is game plan? Strategy, isolate radical symbol, but it's already isolated for us. We don't need to do anything else. Here we just square both sides. And now what do you get? This squared is what? X plus 5 is equal to, now this squared will be x squared minus 2x plus 1. Okay? Now here, same idea is get 0 on one side. Always try and get 0 on one side when you have degree 2 so we can use our factoring techniques. Okay? So here, if we were to get 0 on one side, let us minus 5 minus x minus x. So what do we get? 0 is equal to x squared minus 3x minus 4. Okay. And me personally, I hate it when the 0 is on the left side. So, I don't know, just me being OCD, I just write it like this. It's the same exact thing. Okay. And now here, how does this break? This is x minus 4, x plus 1 equals 0. And now we have x minus 4 equals 0, x plus 1 is equal to 0. So x is equal to minus 1, x is equal to 4. All right? And if you just run away and say, I'm done, no, check, 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 check. So here, we got to check them. Let's check one of them here. So here, x is equal to 4, right? Let's check this one. X is equal to 4. So square root of 4 plus 5 is equal to, because you see here you're plugging in 4 into the original. 4 plus 5 is equal to 4 minus 1. Square root of 4 plus 5 is 9 is equal to 3. 3 is equal to 3. Check. Okay, so this is check. What about the next one? Let's check this one. Check x is equal to minus 1. Now here, what happens? You have square root of minus 1 plus 5 is equal to minus 1 minus 1. But this is square root of 4 is equal to minus 2. Square root of 4 is equal to minus 2. Square root of 4 is equal to 2. Square root of 4 does not equal minus 2. So 2 is equal to minus 2. And this is an extraneous solution. Okie dokie. Alright, what about the next one? Number 1, the first question. For some reason they gave the more difficult question over here. So here, what happens? Here, we want to isolate the radical. So here we're going to do minus 1, minus 1. So now you have 3x minus 1 is equal to 2 square root of x. Okay? Yeah, let me write that again. So 3x minus 1 is equal to 2 square root of x. Now here, if you're saying let me divide 2 on both sides, you can, but you don't need to. All you need to do is just square both sides. Okay? And that will get rid of this radical. Now 3x minus 1 squared should equal 9x squared minus 6x plus 1, and that's equal to 4x. Okay? Because here, remember, it's the same idea here, what we did here. Remember, 2 square root of x squared is just equal to 2 square root of x times 2 square root of x. 2 times 2 is 4. Square root of x times square root of x is x. And that's equal to that. Now here, same idea as always, get 0 on one side. You see, here we have degree 2. We can use our factoring techniques, right? So now here you have minus 4x minus 4x. And now here you have 9x squared minus 10x plus 1 is equal to 0. And if you're thinking, oh, what two numbers when I multiply give me 1, but when I add give me minus 10, be very careful. Here, our coefficient was what? It was 1 here. This one, our coefficient was 1, and we could break it like this. Here, we can't say that. Our coefficient is 9. Can we factor something out? Can you factor out a GCF from 9, 10, and 1? You can't. You have to use AC method. Okay? You have to use AC method. So here you're multiplying the 9 to the 1, so this is 9. So what two numbers when you multiply give you positive 9, but when you add give you negative 10? That's negative 9, negative 1. And this breaks to what? 9x squared minus 9x minus x plus 1. Okay? So now we got a factor by grouping. Factor by grouping. So here, what do we do? To factor this by grouping, you just go divide to factor out the GCF, factor out the GCF. The GCF of this is 9x x minus 1. And here, you want to factor out a minus 1 to get x minus 1. And now you see the two binomials are the same. 9x, oh, and remember, this is all equal to 0. All equal to 0. So here, 9x minus 1 times x minus 1 is equal to 0. Whew, what a problem. Okay, so now here, 9x minus 1 is equal to 0, x minus 1 is equal to 0, x is equal to 1, x is equal to 1 over 9 over here, right? Because it's plus 1, then divide by 9. So we got it. Now we got x is equal to 1 over 9, x is equal to 1. But it's not enough. You have to check it. So let's just check it over here. Let's do it on this paper over here. Alright, so x is equal to 1 over 9. Check. Let's see. If we have the original problem is 3x is equal to 1 plus 2 squared of x, right? This was the original problem. Now here, just plug in 1 over 9. And I know if you're thinking fractions, well, just get used to it. So it's 3 times 1 over 9 is equal to 1 plus 2 times the square root of 1 over 9. And if you're thinking, oh God, I got to take the square root of a fraction, it's not too bad. But let's see. Let's do this. 3 times 1 over 9, this is just 1 over 3, right? Because 3 times 1 is 3, 3 divided by 9 is 1 over 3. 1 over 3 is equal to 1 plus 2. Now let's see. Square root of 1 over 9 is equal to the square root of 1 over the square root of 9. You're allowed to do that. If you have square root of a over b, you're allowed to say the square root of a over the square root of b. You're allowed to take the square root of the numerator and denominator. Square root of 1 is just 1, and square root of 9 is just 3. So this is just equal to 1 over 3. So this is 1 over 3. So 1 over 3 is equal to 1 plus, well, 2 over 3. And that is incorrect because, I'm sorry, not that it's incorrect, that this will be false. 1 over 3 is equal to, well, 1 is equal to 3 over 3. Right? 1 is equal to 3 over 3, so 3 over 3 plus 2 over 3. 1 over 3 is equal to 5 over 3, and this is false. False. So x is equal to 1 over 9. This is an extraneous solution. This doesn't work. Alright? And what about this one here? If we were to have check x is equal to 1. And our original equation is what? 3x is equal to 1 plus 2 squared root of x, right? Here, x is equal to 1, so 3 times 1 is equal to 1 plus 2 times square root of 1. But 3 is equal to 1 plus 2 times 1. Square root of 1 is 1. 3 is equal to 1 plus 2. 3 is equal to 3. Check. Whew. That was a lot of work. So when I said that this section would be difficult, I meant it. It would be very difficult. Okay, another video for the next part of the lesson.